All right, hello everyone. This is Mr. Crozier, and I wanted to give you some help and some clues on round 15. So here we go. Problem number one. Which of the following statements below are true? Well, just go through and check each one off and see which ones are true. First one is talking about the derivative at 3. Is that greater than 0? So think about the slope here of this line. The second one is the second derivative. That's the acceleration. Think about the acceleration. You might want to look up about mins and maxes in the graph here. And number 3, again, talks about the derivative, but in this case, it is the derivative of x, which means any value. True or false on each one? Pick the correct answer. Number 2 is an equation that needs to be solved, and the thing to realize is the variable is up here as an exponent. So we need to get that down, and the best step usually is take the log of both sides. If I take the log of both sides, I can bring that exponent down, and I would have log or 2x log of 7 equals log of 4. That's a problem that can be solved now with some basic algebra steps. Going on to number 3, suppose the vectors a and b are determined by this change right here. We're multiplying a by 3, 2 by b, and subtract it. Just start with 3 times this vector and 2 times this vector and keep them as vectors the whole time. Don't change them to just values. Make sure they're vectors all the way throughout. You'll have the right answer. Going on to number 4, this is a mixture problem. And the key formulas to remember are that it is a 10-liter mixture. So you have x being added to y to making 10. And then the other equation is about the percentages. So it's going to be 0.01 times the first one times 0.035 times the second one is equal to 0.2 times 10 because that's the total. Use some substitution there. Should be able to solve it. Number 5, solving this log problem. Well, our number one step is to get it to a single log so we can write it as an exponential and solve. And if we're adding two logs, we can multiply them if we combine them. So we have log base of 2. And if we multiply these things, hopefully you realize that's the difference of squares. X squared minus 1 is equal to 3. And now you can convert it to an exponential, which would be 2 to the third power x squared minus 1. Solve that. Pick the right answer. Number 6, solve this system of equations. Well, what do we have here? We have, how about a substitution? How about I solve this one for y and I swing that over there and swing that over there, and that becomes 3x plus 2 is equal to y. And swing this over here, and I have 2x squared is equal to y. They both equal y, so I have 3x plus 2 is equal to 2x squared. Solve that, and you're on your way. Number 7, a plane flying level to the ground. The plane's airspeed is 450. Let me draw a picture of this bearing, and let's call 0 degrees straight north. Well, the plane's flying northeast. That's this direction. If I want to write it as a polar coordinates, that's 450. How about to 45 degrees? And the wind, however, is blowing due east at 70 miles an hour. That would be 90. Well, you can have these two polar coordinates. First thing I would do is add them together in terms of rectangular coordinates. And then once you get those, you can take the inverse tangent of that and you should be set. And remember, the rectangular coordinates are going to be the magnitude times cosine of your theta for both of them. I'm just going to go ahead and write it out like this. That's the first point, first vector, second vector, and magnitude sine theta plus magnitude sine theta for the second one, and then the tangent inverse y divided by x. Problem number 8, it's a chain rule problem. You have to take the derivative of, we have a function in which we have a function with another separate function buried inside of it. So our plan is to take the derivative of that first function, leaving it alone, and multiplying it by g of x. All right, number 9. How many solutions are there to this equation? Well, we have to solve it, and I would set it up, kind of looks nice and neat for elimination. If we put this right underneath of it, then we couldn't we just multiply everything by 3, subtract, and we'll be able to solve this equation. Number 10, solve for x. Here again, we have variables in the exponent. We're going to try, we can pull that down because it is a log function. So now we have x squared, natural log of 5 equals natural log of 3. Divide both sides by the natural log of 5, and then take the square root of both sides. Don't estimate till the very end. Number 11, it's our definition of a derivative, meaning we have to find a derivative at this point. So we're going to get there by using the slope formula, right? And we're going to take f of x at the point x, and we're going to subtract it from the value of 2. If I plug in a 2 here, I have 2. If I plug in a 2 up here, I have f of 2. Now, if we take 2 and we plug it in the left side, we're just going to zero everything out and it's not going to work. So what we have to do is simply find the limit as x goes to 2. So if you can run it through these and simplify it from there, simplify the top, you should get the right answer. For the f of 2, you can plug it in and get that value. For the f of x, use the function. Number 2, determine the angle between the two vectors. Well, that formula is cosine of the angle is equal to the dot product of the two vectors over the magnitude of the two vectors. Or I'll give you another plan to do this. How about just graph it? Take a coordinate plane, try and make it as neat as you can, and plot the two vectors. You should be able to find out what that angle is. Fairly simple. Number 13, plane M contains these points, plane, and plane M also contains the point 3, 4, 1. If the line passes through it, what is this value? Well, this is a parametric equation right here. It's telling you what's going on in the x, y, and the z for the a, b, and the c. And the x, y, and z can be written this way. And the starting point is this point right here. And then what we do is we need to add on a t value. So these are the numbers you're looking for here. You're looking for what do you put in these t's to make it change. And the key is it's perpendicular. And perpendicular is done by the cross product. So doing this cross product is going to give you the coefficients for the t's. But be careful, depending on which one you put on top, the 3 or the 1, you get either positive or negative. Try it with this on top. See if you can get one of these values. Try it with, if that doesn't work, try it with the other one on top, and one of those should work. Number 14, solving equation problems. The equations you're looking here are the two investments add up to $10,000, and the other equation that you're looking for is the interest for this one, and the interest for this one, total 283. Use some substitution or elimination, you will be at your answer. Definition of E. The correct answer here you're looking for relates to compound interest. I'll let you look this one up and see if you can find this. But this version of E is related to compound interest. Problem 16, very straightforward log problem. We got to find it. The best way to do it is to simply convert it to an exponential, and that's 5 squared is 3x minus 1. 17, again, same deal. Natural log is base e, so it's e to the 4th is x minus 1 over 2x. And take a look at the answers on this one. There's no estimation here, so don't type in a value for e. You have to use e throughout. If I multiply by 2x, I have 2e to the fourth x minus 1. Subtract off the x, and I have negative 1. If you factor out a x, you have 2e to the fourth minus 1, negative 1. X is equal to negative 1 over 2e4 minus 1. Not an answer, but if I factor out a negative 1 from the top, I have 1. If I factor out a negative 1 from the bottom, I have 2e to the fourth. Problem B, answer B. 18, what's the derivative of a natural or an exponential function? Well, this derivative is very simple. If we have anything to an x power, whoops, it's not a derivative there. If we have anything to an x power, its derivative is simply the same thing times the natural log of the base. Number 19, what's the equation for the plane? There's a plan for this, which I don't think we can get done in 45 seconds, so our plan is going to be to guess and check. Unless someone comes up with a faster way, guess and check. These 3 points will work in one of those equations. Number 20, given the points, if they're collinear, then the determinant is 0. Here it is 0, means they are collinear on that one. Number 21, what's the slope of the line perpendicular? Well, if you take the derivative, you will get a tangent line. So we don't want tangent lines, we want the perpendicular to that. So obviously what we have to do is we have to take this slope that is determined by this and do the opposite reciprocal. You will have your perpendicular line. 21 or 22, sorry, solve the system of equations. Well, you can do it however you want to. I probably see it the easiest. I bring the 1 over there and it's x plus 1, bring the y over there. Now you can plug that y in there and you have x plus 1 is y squared plus 1. Solve that equation, probably done by factoring easiest, and you are finished. Alright, I hope these clues help. Good luck on the round.